All right, I think we should start now. So Arvind here has run successful Kickstarter campaigns for previous RPGs like Unrest and Will Fight for Food, and he's been around for a while and doing good stuff. And I'm really looking forward to his new game, which is Good Robot. It's a procedural generated bullet hell kind of game.
Bullet hell.
And yeah, so he's going to talk a little bit about how he came up with the procedural generation part of it. And so please welcome Arvind.
So yeah, so my talk is about procedural generation and how it relates to what I did for my game. So I'm Arvind. I run this company called Pyrodactyl. We made a game called Unrest. It was an RPG set in ancient India. It had like exploration and a bit of mythology elements in it, and it had a conversation system, which it was very detailed in terms of what it did with tone and emotions and stuff like that. Then I made another game called Will Fight for Food, which was a comedy brawler. And again, it had a conversation system where you chose between body language, opinion, and tone. And now I'm making this game called Good Robot. So it's a roguelite shoot 'em up. It's procedurally generated, and I'm going to talk a little bit about how I made the game. But before that, let's discuss the few terms that we'll be using over and over in this presentation. Oh, okay. So shoot 'em ups. We know what shoot 'em ups mean, right? All of you have, I hopefully, played some of them. So essentially, they are games which are two-dimensional, have a lot of enemies, and involve usually a test of reflexes. So games like Geometry Wars, you have Crimson Clover, right? These games are also called bullet hell games because usually you have like 500,000 bullets and like everything's just crazy, right? If you've played Space Invaders, right? Take Space Invaders and turn everything to 11. That's what a shoot 'em up is. Then procedural generation, right? So it's the process of generating in-game content that normally is associated with artists and specific people for that content, but you generate that via code. So for example, in Minecraft, right, they generate the world using procedural generation. So you can generate weapons using procedural generation, like Borderlands, for example, and lots of other stuff like that. And usually when I mean procedural, I don't mean 100% random. There is an algorithm behind it. So like people will say like, random, the game has random levels, but they're not actually random, they're algorithmic. So again, Minecraft, you probably heard of it. Spelunky, that's a good example. It has a very basic procedural generation, but it is incredibly easy to understand. And it's a great template if you want to start procedural generation, because that's basically what I did. And roguelikes. So roguelikes are a genre that has been in the ascendancy lately, and they are turn-based, they have tile-based levels, and they have permadeath. And they are usually known for their difficulty, right? And what happens is you play through the game, you die, and the next time everything is different. So, and a roguelite is a game that is not 100% roguelike. Like roguelikes are so like advanced that they even have an index, which is like a list of 10 things a roguelike must have. If you only have 8 things, then you are a roguelite. So it's like, Bud and Bud Light. Like that's. So this is Rogue. When somebody says roguelike, right, what they mean is that the game is like Rogue, which was it's a very old game. It's text based. You see like the little @ symbol over there, right? That's the player character. So everything is drawn using ASCII art. So this was a very old game, but people are still playing it today because of the incredible depth that it had. You have a lot of scenarios and things that can happen in there, because roguelikes, what happens is they are procedural. So they have these discrete systems, and how those systems interact is what gives a roguelike its depth. Then this is NetHack. It's a pretty famous game. Hopefully some of you have heard of it, right? So yeah, NetHack is another example. This is actually a GUI layer on top of NetHack. Otherwise, NetHack also looks like Rogue. And now we come to what good robot is. So when I talk about the procedural things in good robot, specifically I am making these three things via procedural generation: rooms, levels, and weapons. So let's go through those one by one. So a room, right? In good robot, the room is an n by n matrix of tiles, similar to how you saw the ASCII art, right? Except what we do is we add graphics and such, so the tiles don't actually look like tiles. And it's pretty simple in the way that one tile, right, one unit in the n by n matrix can only be either solid or empty, right? There can be conditions associated with it, but at any one point a tile can either be solid or empty. And in the empty space, we designate enemy spawn points. So this is what a level in good robot may look like in the editor. So I'm going to go through how it works. So we generate these levels procedurally, right? But we generate them in a format so we can also look up the levels in an editor. Because let's say you have a procedural level, right? And then at the end of level 1, you want a boss. And you want the boss fight to happen in a certain arena. So for that point, you actually, the way we built it is that we can turn off procedural generation. We can tell the game, look, here's the map file. You load this for the boss fight. So we actually use a combination of both. So the format is actually, if one of you has heard about Tiled, it's an open source map editor, which is pretty easy to use. So yeah, check it out. Then the tile types, right? So the black tiles that you see over there, they are solid tiles. As in, for every time this map is loaded, these tiles will be solid. And the blue tiles are the empty tiles, where they will always be empty. Then the green tiles are exit tiles. So what you have, like, let's say we generate a maze, a procedural maze, right? So not all of the exits will be open at any point in time. Sometimes there might be a condition behind it. Sometimes the maze is just generated in such a way so you only need exits at, let's say, the top left and the bottom right, for example. So in that case, the other exit tiles will be permanently off. And the fourth thing is group tiles. So you see those two specific things. One is yellow and orange, and the other is the dots, which are of two different colors. So these things are actually tied to in-game scripting hooks. So for example, if you want like an enemy to suddenly pop out of the terrain, right? The terrain should explode and the enemy should suddenly come up. So you tie that into the scripting like that. So these tiles have specific conditions. So in this screenshot in particular, right? The dotted ones have a unique feature where if one of the dotted tiles is empty, right? The other one will be solid. So it's sort of used as a puzzle element. So you have to toggle the visibility and like press switches in it and stuff like that. Then there are the spawn points. So how we do spawn points is once the level is generated, like each enemy has a different type of attack and each enemy has a preference. So let's say there is an enemy which wants to ambush you around corners, right? So the game will say, okay, this level is supposed to have an enemy that ambushes you around corners. Let's find out where such a spawn point is possible in the map. So for example, here the game might hide that enemy behind that central square block. Knowing if the player is going to come from the top hand side, then that will be a point where they can possibly be ambushed. So what you do is you set a preference for the enemy, and that's how the enemies, they basically decide where to spawn. So you have three enemies, the game will decide, okay, this enemy goes in here based on the preferences that you have set for the enemy. So, and that's how this actually ends up looking in game. So the quality is kind of low, but here you can see like a group of enemies at the bottom. Then over there, it's actually a big like semi-boss kind of thing. So that's how these levels end up looking. And now levels. So you have a room, right? Then you have to tie those rooms together. So, and we call those a level. So, and in levels, you also have to decide checkpoints, like a special room, maybe a place where you get a new weapon or something like that, and boss locations. And you ideally want a lot of variation in there. So what we do is, like, I'm going to tell you the algorithm. Oops, sorry. Hang on. Yeah. So this is an empty level in our game. It's again, it's an n by n matrix of rooms. And what you have here is the green spots, right? They are exits to a different room. And all of them right now are open. And the rule you follow is what I've written down here. Essentially means that an XY room, right? That and the X minus 1, Y, the rooms adjacent to it have to be the same exit. So the player can actually travel through it. You get what I'm saying, right? Like the matrix edges have to match. So after that, what we do is, like, these are all the permutations a room can be in. So the permutation is decided by how many exits are open in that room. So you have like doors on all 4 sides, doors on 3 sides, 2 sides, 1 side, and a closed block. And you can use a structure like the one below. It's obviously very simplified, but yeah, something like that to keep track of what a room's properties are. And what we do is we use a function that's kind of like this to randomize the rooms. So how specifically we are randomizing the exits in the room, right? So you loop through each of them, and you, based on your probability function, you can just close or open doors as necessary. So in here, for example, there is a 50% chance of an unvisited door being open or closed. But if you want a more open maze, you can have a 75% chance. Or if you want a more linear set of levels, you can do something like an 80% or something like that. So this is sort of the algorithm that we use. But so here's how this works, right? You first pick a random room, that's your spawn point. So in figure number 1, that's the room in red. And then you run that randomizer function, which I just described earlier. And in figure number 2, the randomizer function has closed 2 doors, right? So the next thing you do is you go to the empty rooms in there. It's similar to a flood fill algorithm, right? You are essentially creating the shape and then flood filling it. And so like how this works is, then you see those 2 rooms in yellow, right? Figure number 2. The game will run the randomizer function on each of those rooms. Then you get something like figure number 3. So in this case, the game knows that like we have already visited the room in red. So now the rooms that are in yellow, the 4 rooms, those are the ones that it will run the randomizer function in. And so on until it reaches there are no rooms left. If you like know about flood fill algorithms, right, it's essentially that. So, and you end up with something like 4. So 4 is the final level, and then the blue point is the end point where the portal to the next level is. So how we decide that is we just compute the distance. The game knows how to path through its own level. So it will say, okay, the exit must be 5 rooms, at least the minimum distance to get to the exit must be 5 rooms. So it picks a spot, and that's the exit. So that's how a level works. Then we have procedural weapons. So how we do procedural weapons is, let's say you pick a game like Borderlands, right? You've played that. How do they do procedural weapons? They have predefined parts, let's say like a shotgun, right? And they will modify a few properties related to that. So that shotgun might have a low magazine size, but a high damage rate. So we do something very similar. It's a 2D shoot 'em up. So obviously it's not exactly like a 3D game, but we have properties like, are the projectiles the weapon spawns affected by gravity? If yes, then it becomes a kind of a laser gun, right? But if no, it becomes a laser gun. But if yes, it becomes a projectile weapon, like a grenade launcher or something like that. Then can the weapons bounce off walls? Can they bounce off other enemies? Are the weapons explosive? Can the weapons hurt you? And we have a ton of properties like that. And what we do is we run a randomizer function, but we don't take every single weapon. We keep the good ones, because in a 2D shoot 'em up, the weapon feel is very important. So if you have 100% procedural, let's say you give it to somebody to review, right? By Sword's law, it's going to happen that they will end up with a lame weapon and they will hate your game, right? So what we do is we take the good weapons and we create a database of these are the weapons that are actually acceptable. And then the game tries to generate weapons as close to it as it can. And again, we have a item system that's similar to, rarities, common, epic, rare, etc. But since our game is kind of futuristic, we call that ordinary, executive, this is the future. And how we do it is that an ordinary weapon will have like two positive things, but it will also have a drawback. So for example, we have a frisbee, right? A frisbee that bounces off walls is a positive trait. But if it can bounce and hit you and damage you, that's a negative thing. So that's something which we actually have in the game, where it's a frisbee that bounces off walls but has friendly fire on. So if you're not careful with the angle, then it will come back and hit you. And let's say I want to make that weapon, but I want to make it like the next tier, like the executive tier. So what I will do is, I will add that the frisbee explodes whenever it touches something, right? So it touches an enemy, it bounces, but it also leaves a slight explosion. So suddenly it's way more powerful. But at the same time, I will make it so that it does 2x damage against you. So if you get hit by it, now it will do double damage to you, essentially a critical hit. So that's how you make kind of like, weapons with unique feel. So, and what we do, another thing is like weapon drops, right? If you have played a game like Diablo, Torchlight, they have a constant stream of new weapons and like stuff you can play with. So we try to have a sort of steady stream of things. So what we tried initially was that you have a certain specific chance of an item in the room, like in a room that you go into, right? But then that becomes kind of like sometimes, just like you don't roll the right numbers and you end up with a long gap between things. So what we did actually was that as soon as you get an item, right, the game will roll what number of rooms will the next item be in. So that way, even if you roll a slightly bad number, you'll eventually get it, and then you might roll a better number next time. So this is actually what also like Valve did with TF2 item drops, where instead of having a chance to drop an item, the random number generator rolls when your next item will drop. So that creates a much more, it's much less frustrating because the player doesn't feel like they have to keep playing the game to roll the dice as many times as possible to get the right amount of weapons. So here's one example of a weapon in the game. Now it's a laser, right? And it has a thing where it bounces off walls and it's slightly persistent. By slightly, I mean like for about, let's say 10 milliseconds after the laser is fired, it will still hang in the air. And so you can sort of like you can lead the enemies in that way. And so here, like that's how it actually looks like in game because you can keep on firing it. It has a very high rate of fire. So this is one case where if you think about what the weapon properties are, the first thing it has is that it's a beam type weapon, right? The second thing is that it bounces off walls. And the third thing is that the beam also has a very slight, a very fast projectile that stays in the air for a little bit. So that's how like a weapon like this is actually divided in-game properties like that. Then we have these, we call them the bubble gun. But what it essentially is that these are very slow bubbles which will explode into their own bullets. So it's very easy to hit enemies with those, but at the same time, they will also hit you. So it's sort of like you fire the bubble gun and then you yourself also dodge while hopefully hitting enemies. So again, if you dissect that in properties, right, what actually happens is that the projectile is the parent projectile. It has a large number of child projectiles, and it has friendly fire on. So you take these weapons which look and feel very different, but they are built on top of this system, which has a ton of properties, a lot of which are basically just booleans that somebody can just toggle on and off for the desired effect. So that's how the weapons work. Then we have the upgrade system, which is, like you level up and then you buy things. So this is actually not procedural because The first thing is that upgrade trees usually need to be designed by hand. So the values, the properties that you increase, they actually feel like you leveled up. So the four basic things, the directions that you can upgrade your robot in are attack, speed, shields, and rate of fire. So all of these have these little perks, but essentially, let's say you're upgrading attack. What you are actually doing is that you are insuring yourself in case you get a bad weapon that maybe you are not that good at with. So for example, if you prefer hit scan weapons, right, and you get a projectile. So until you get that next weapon, you at least having a high attack means that even if like you miss every other attack, you still do enough damage to survive. So that's what I mean by a semi-alternative method of progression, is that you buy these upgrades to sort of insure yourself in case like you get a bad weapon or something like that. And then like we are a roguelike, so that means permadeath. But what we have this thing which we call a warranty. But what you do is, it's a very high cost upgrade, but you buy that once, and once you die, right, it's an extra life. So once you die, it will respawn you at the start of the nearest level. But what this warranty does is that if you buy a warranty, then the cost of everything else in the game will increase. So it's a matter of you will get less upgrades because like you're choosing like insurance over power. So that's how we maintain the roguelike feel. So even if somebody buys a warranty, that doesn't mean that they keep on buying the warranty, because the next time the warranty price will increase in a very steep curve. So that's how we do this thing. Then we have a small amount of plot in the game, which is, so I'll just tell you what it is. The good robot wakes up in a factory, and the factory is underground because the climate change has essentially flooded the earth, right? So everyone lives in caves. That's why you see all those caves in there. And what happens is that the plot, as you go on, is told like a news broadcast. So you have these news kiosks, right, that you can read if you want to. And the story is slightly procedural because it's sort of like, cause and effect. If the player kills a boss, right, the news will sort of change to reflect that. So this is actually something which we ported over from our previous games, Unrest. That was a role-playing game. So role-playing games are all about choices and consequences, right? But we tried to include some of that in a roguelike. So essentially you have these series of events which have these triggers. So for example, if boss number 1 is dead, then the news will slightly shift towards that. But they'll also have other headlines. So it's our attempt to kind of make a procedural plot, essentially. So in general, right, when I say procedural generation, so if you want to add procedural generation in your game, first thing is you ask yourself, what role does it play? What parts do you want to procedurally generate? Do you want to, like, the levels in the game to be different? Do you want your game to have a lot of weapons? Like, what kind of game what kind of a game do you have? If you have a Spelunky style game, right? But you cannot just use value noise, whatever comes out. You need an algorithm to make sure that the jumps are possible, that the enemies are actually placed in such a way that the player can see before they actually interact with them. So, and again, like, if you're making a procedural game, that doesn't mean that you need to make every single thing procedural. You can take one thing that you make procedural while tweaking the rest of the things by hand. In fact, a lot of, like, for example, Borderlands, right? They don't, their levels are not procedural. All they do is that the guns they have are slightly procedural. So that's what you do. And the final thing is that even if you get the values from procedural design, right? That doesn't mean that you cannot tweak them. Like, the algorithm is not like holy. So you tweak the procedural algorithm, you can even add like some special cases. So for example, if your algorithm produces something good 70% of the time and 30% of the time it's not enjoyable. So you try to keep that 70% output preserved and add a special case for when that 30% happens. So you have something to avoid that. So essentially that's what procedural generation is. You are essentially, you are a programmer, and now you are also playing the role of a level designer or like a game designer or a scripter. So the algorithm is something which you should tweak. Like, it took us about 8 months to get the level generation thing right for our game. So So yeah, that's what it is, and yeah, I'll show you the trailer about how the procedural generation fits together. So yeah, if you notice something like the enemies actually use the same projectile system as the player. That's another good way to balance it actually, is that, hang on. So yeah, one thing which we also do, which I sort of forgot to mention, is that the enemies also use the same projectile system as the player, which is actually a great way to balance it, because let's say you come up with a weapon that takes a minute to warm up, right? It's not suitable for the player. But if you actually increase the power and maybe the projectile size, that's a great weapon for a boss to have. So what we actually do is that we use the same projectile system for the player and for the enemies. But the enemies have a different set of operating parameters essentially. So for the enemies, it's all about like balancing weapon power with their rate of fire, making sure that an enemy doesn't give the player any chance to react. So for example, we don't use a lot of beam type weapons for enemies, because beams travel instantaneously. But that's a great weapon for players to have, because they can bounce beams across corners. And one thing which we do is like, we give enemies, sometimes we give enemies bouncing projectiles, but not a lot, because the enemy algorithm can actually shoot the player before they see them. So while that is the player feels very clever when they do it. But if the enemy does it to them, then that feels unfair, because you get hit by a bullet from nowhere. So what I, at least for our game, and what I recommend is, like, try to, if you're making a weapon system that's procedural, right? It doesn't make sense to only use it for the player. Also use it for the enemy. See how that feels. Like, see if the system can come up with enough weapons for the enemies to feel wearied. And like, you can have different movement types. Like, we have enemies which are of like which are like terrestrial, so they can only move across ground. Then you have enemies which can float. Then you have enemies which sometimes teleport. So try to think which weapon makes sense with which. So for terrestrial enemies, it makes sense to give them homing missiles, for example, because if the player can just fly above and shoot them while the enemy cannot like accurately fire at them, then that kind of makes the enemy feel a little bit inconsequential. It feels like just filler. So you try to have a system where the weapons complement the enemy movement types, because then what you will do is, perhaps you might want to introduce different robot types for your game. And then maybe you make a procedural, you make a terrestrial robot, right, which can jump. Then you have a valid set of weapons to start off with. And yeah, essentially that is pretty much it. So yeah, so that's how we did procedural generation in our game. If you guys have any questions related to stuff like.
Hi, have you planned? Okay. Do you have any plans on making a 3D game, and if yes, how would you proceed to make environments for that procedurally?
Do you mean like how do I make environments for procedural?
Procedural environments for a 3D game. Do
Oh,
you
for
use
a
a similar
3D game.
techniques or something else?
So for any game, if you want to make a procedural environment, right, the first thing that you do is try to divide a typical level into its core components. So let's say you are making a procedural third-person shooter, right? So if you are making a very basic third-person shooter, then what you do is, let's say you have an empty level, you have objects of varying height. You have a chest-high wall, you have a very high wall, you maybe have a wall that comes up to here. So now you have these 4 components to work with. Then you try to lay them out in such a way that it creates interesting levels. But for that, you need to know what your enemies do. So if you have an enemy that has a rocket launcher, they will probably need to be slightly far away so that the player can maybe shoot down the rocket. So that's essentially what you do. First, you divide everything into its discrete components. And then you try to algorithmically place those components so that like it creates something interesting.
Thank you.
So you were talking about loading levels, right? So what about unloading the levels that you've procedurally generated? So do you cache you were talking about levels as blocks, right?
Yeah.
So say you've generated a level and the players progress far enough. So do you keep all that in memory, or do you like unload them?
What we actually do is that the levels, right, they are just simple data blocks. They don't take a lot of memory to store. And the textures are laid out separately. So what the game does is that it just looks at which level you're in and like the level before and after that, and it will just lay out the geometry and render it. Because what you're doing is just you're storing one n by n array, right? So it's not that, like it doesn't tax your memory a lot. And the way if you're making a procedural game, your art has to be discretely divided. So what we actually did for this was, there are a lot of layers. Like you have seen like some like lights and stuff, some buildings on the side. So that all stuff is like components, and we just place them according to the level. So the texture memory is separate and the level memory is separate.
Yeah, Arvind, how do you debug Arvind?
Oh,
How do you debug a procedurally generated level? Because it
by
might
debugging, like what's the bug here that I'm looking for?
sometimes empty rooms or like dead ends
Yeah,
basically.
that's actually why what we do is like you saw that level which I showed, right, which was in a. So what we do is you can at any time output a level into a TMX file. So you can see what that level is, what was the value that we passed to the algorithm, which resulted in that number, and then we can like step through that and see what the problem is.
Hello, I have a question. So first I would like to know what technology are you using to build your game?
C++, OpenGL.
Okay, so next question is, since you are doing that procedural stuff, are you giving some training data? Like if it goes to level 10, you're using all the data that you aggregated from level 9 and using it to make better decisions in placing the props and stuff?
Like it doesn't happen like that. Like you don't just like collect data from level 9 and then use it in 10. Like you collect data through testing.
Okay.
And then you make sure that the game you ship with has already like all of the lessons that you learned.
Okay.
And what we do specifically to give each level a different theme is what I discussed earlier, right? Each enemy has a preference for where it wants to be and where it wants to spawn. So you have different types of enemies in different levels, and then you sort of tweak the algorithm to create levels more suited to the enemy. So for example, in the starting level, right, the levels will be a lot more open. There won't be a lot of corners. You can see the enemy from far away, stuff like that. But then like as you go through, let's say like level 5, right, by that time, the algorithm essentially like takes the gloves off. And then it starts creating levels that are suited more to the enemy than to the player. So that's how you slowly escalate the difficulty like that.
Okay, so if I have to going to ship my game, so I have to analyze how long the time will take for the algorithm to generate. It's not like I write the code and give it to the user.
The time has not been a problem for us because again, like texture memory is just like loaded, right? And these are just like simple n by n blocks of data, which like it's not expensive at all. All you're doing is storing a few ints, a few booleans. It's not really like performance. It's not performance intensive. All that matters is like because the level generation algorithm, it generates a level and then it hands it off. So now the work of the algorithm is done until you load the next level. So it's not always running in memory. It just generates a level and then it hands it off.
Okay. Okay. So one last question. This is not related to procedural. So like so many projectiles are flying off and here and there. So how do you handle that collision detection? Is it happening for every object in the scene or?
Yeah, it is.
Okay.
It's just like collision detection is actually something entirely separate. The algorithm doesn't care. It just like wants to create open spaces, right? And then the collision is just like some other thing. Like we use like our own physics engine. Like it's an entirely separate thing. So like it's 2D collision detection. By now, like you can find a lot of resources on that, and like yeah, that's what we use. So okay. It's not related to the procedural element.
Yeah. Okay. Yeah. Thank you. Yeah.
The others also need to hear.
Hi, I was a bit late, so I don't know if you spoke about it. Have you thought about procedurally generating content, as in art, for not for like stuff like doors and weapons, but rather like maybe weapons also, but let's say backgrounds or even textures which keep changing?
So procedurally generated art is possible. But it's also something which, like I said, like you don't necessarily need everything to be procedural. So the reason we don't do procedural art is because let's say you want an icon for the exit, right? Like usually like it's pretty like known that you have a green door with an arrow in it, or maybe like a stick figure is running through it, and that's the universal exit icon. So that way we don't have to localize, because usually that's what an exit is everywhere. But if you want to have like that procedural, right? And that suddenly becomes like, is the icon recognizable, and like, because art-wise, most of the output will probably be garbage.
No,
so
not just, not like things like, not doors or things that are like, that work or something, but rather the texture for, let's say, like a wall or like a, even like you had a backdrop which was like kind of parallax, which was far.
I haven't tried that because I think procedural art is very tricky, because with art you end up with questions like, does it look good, does it suit the theme and stuff like that. So that is in my opinion, that's a way more complicated problem than what we have done here. So yeah, like if you want procedural art, then like the algorithm will actually need to make decisions like, does this look good? Like, is the shape that I have made like recognizable? Is it not like garbage? So it's procedural art like is possible, but at the same time, it's very tricky. Most of the procedural art that you see, right, is usually made up of simple patterns that like checkerboards and stuff like that. And even what they often do is like they will have some patterns and then they will mix and match in between those patterns. So you assume that like if all of these patterns look good individually, then a sum of them will also probably look good. So yeah, but procedural art, like that's what I said, like you don't necessarily need everything to be procedural. So yeah, like it's possible, but especially for a game where we had like a 1-year deadline or something like that, right? So we don't have the appropriate time to like try with procedural art.
Do you use the procedural generated data to for the enemy AI, or do you recalculate it?
Do I recalculate it? When should I recalculate it? I mean, it's generated like it generates it level by level, right? So if you're in level 1, it will generate level 1. It doesn't care about level 2 until you step into the portal for level 2. So, like, is that what you're asking me?
No,
or is
I'm asking for the use of the enemy AI. The enemy.
use of the enemy?
Yeah, AI.
No, the AI is not procedural because the AI needs to make like a certain set of limited decisions. Like, can I hit this player or?
I meant to say the AI requires the knowledge of the map, right?
Specifically, it doesn't. The procedural algorithm requires knowledge of the AI. Because the procedure, like what I said earlier, the AI will have a preference. Like, I can hit players when they are in a straight line with me, right? Or if let's say the AI has a flamethrower. So then the AI has a preference that ideally I should only like see the player if they are in a 5-degree, like let's say 5-centimeter radius around me, right? So the AI just has that preference which like we set. The AI doesn't know what to do with that preference. That's something we decided. And then the algorithm looks at that preference, and that's how it makes the level. So the AI is not like the preference for the AI, right? That's not something that the AI is making a judgment on. That's the procedural algorithm. That is making the decision for the AI based on that. Hopefully you got like.
I was more like on the lines of asking when the enemy needs to know if there is some, suppose say, like there is a wall in front of the player and in between the player and the enemy.
Yeah.
So, do you reuse the data from the procedural generated map or do you recalculate? That was.
Like the algorithm for there is no amount of proceduralness involved in the enemy checking if a wall is between the player and the enemy, right? That is a solved problem. You have bots in Counter-Strike, you have like everything. Any enemy can, all you need to do is just like start a ray from here to here. There's no element of proceduralness in between that. So the AI is separate. The AI does not care about the algorithm that was used to generate the level, but the algorithm cares about what the AI should ideally use. So.
Yeah, I think I got.
In some areas, does it make sense to counteract procedural generation? So for example, you have the attack stat, which you mentioned is a brute force option, that if you aren't with a comfortable weapon, you brute force by having enough damage to make an impact. Could that have also been solved by, say, adding a pistol or a backup weapon in any scenario? Because you haven't mentioned, do people keep weapons or do people change them out one by one?
Yeah. I mean, yeah, that's a design decision that is perfectly valid. Okay. If you are if you're concerned that like the player might end up with, there's a huge percentage chance that the player can end up with, if they have 2 weapon slots, both the weapons can be unusable for them. Then it makes sense to add a third backup weapon which is always present. So yeah, that's a design decision that you can definitely make. It depends on the kind of game you're making, like that's a design decision that's like separate from the rest of the stuff.
What are your thoughts on No Man's Sky, and are you excited about the game?
Yeah, it's looking pretty good. Yeah.
Anything specific that you're really interested about checking out?
I mean, I've seen a bunch of trailers. That's about it. Yeah, I'm pretty excited about it because they seem to be doing a lot of more with procedural generation in general. So yeah, like hopefully it turns out well. So a final question, if. Nope. Okay, then yeah, thank you.